Now the first question, a particle is moving in such a way that its displacement yes, and we have the velocity nothing but 5 minus 8t. Example 5, a particle moving according to law. Question number 8, the radius of spherical body increasing at the rate of 1 mm per second. Find the rate at which its surface area increasing. Example 10, a ladder of length 3 meter rests against a smooth wall standing on a smooth floor. Example 11, a bulb is hung at a height of 20 meter above the ground. A man of height 2 meter height. Hello friends, in today's video I am going to solve some problems related to application of derivatives. Under this I am going to solve rate measure type problems to find velocity, acceleration, time, displacement, and rate of change of volume, rate of change of surface area, rate of change of length, etc, etc, etc. And I am going to solve some 11 unique problems, and these are very IMP questions. Usually this type of question appear in board examinations, and they are useful for the 11th 12th standard students and the diploma in engineering. And so I request you solve these all 11 questions before going to your examinations. And something related to this question compulsorily going to appear in your examination, so I request you compulsorily solve these questions. So let's start today's topic, that is application of derivative problems based upon rate measure. One of my students has asked me, sir, what is the use of derivatives? The question was correct and I must answer to that question. The derivative can be used at many part of engineering. It's a part of engineering, the basic of engineering. It's a backbone of engineering. Without that, you cannot think about the engineering. The very basic use of derivative is to find rate measure, to find velocity, to find acceleration, to find at what rate the volume is changing, to find at what rate the area is changing, to find at what rate the length is changing. So this is the basic use of derivatives. In today's video, I am going to teach you how to use derivative to find the rate measure. That is to find velocity, to find acceleration, to find t. In short and sweet, everything related to kinematics. And the second thing is, when the water is flowing through a pipe or water is being dropped into that certain container, at what rate the speed of water is changing, at what rate volume of the water is changing, or at what rate the radius of a balloon is changing. All these things we can easily find out by using the derivatives. So stay with me till end of the video to solve the many problems based upon the rate measure, that is application of derivatives. Now the first question, a particle is moving in such a way that its displacement s and time t given by relation s is equal to 4t square plus 5t plus 40. Find velocity and acceleration after 2 seconds. Solution. First of all, what is the relation given? S is nothing but the displacement and t is the time, and the relation is given s is equal to 4t square plus 5t plus 40, and we need to find velocity after t equals to 2 seconds. You see, so to find velocity, this is the displacement, and we know that velocity v equals to ds by dt, that is the derivative of displacement with respect to time is the velocity. So this is equals to differentiation of 4t square plus 5t plus 40 with respect to t, that is equals to 8t plus 5. So velocity equals to ds by dt, and we have to find the velocity of the given particle at t equals to 2 seconds. So here t equals to 2 seconds. Now wherever t is there, write down 2. 8 into 2 plus 5, that is equals to 16 plus 5, that is equals to 2, 21. And here the units not given, So it is not given centimeter, it is not given meter. In such case we can write, so velocity after 2 seconds, you can say end of the 2 seconds is equals to 21 units per second. Now we have to find acceleration. We know that acceleration nothing but rate of change of velocity. So velocity nothing but given by 8t plus 5. Now acceleration equals to rate of change of velocity, that is dv by dt, that is equals to differentiation of 8t plus 5 with respect to t. So that equals to 8. Therefore the acceleration of particle, acceleration let us say denote by a. So a equals to 8 units per second square. This is the solution of this question. Now question number 2, a particle is moving at time t whose displacement s equals to 20 plus 5t minus 4t square. Find its acceleration when the velocity becomes 0. Solution. First of all, what is displacement given? Displacement given s is equal to 20 plus 5t minus 4t square. Now to find velocity, the velocity is equals to rate of change of displacement, that is ds by dt. So that is differentiation of s with respect to t, 20 plus 5t minus 4t square with respect to t equals to 0 plus 5 minus 8t. Therefore the velocity v equals to 5 minus 8t, and we need to find acceleration when velocity becomes 0. If velocity equals to 0 implies v equals to 0, implies 5 minus 8t equals to 0. So minus 8t equals to 5 and t equals to minus 5. Therefore t equals to minus 5 upon minus 8. So t equals to 5 upon 8. Now acceleration, we have the velocity nothing but 5 minus 8t, acceleration nothing but rate of change of velocity dv by dt equals to differentiation of 5 minus 8t with respect to t. That is equals to minus 8 units per second square. Minus standing for retardation, because the body is going to be 0 velocity, so there is a retardation. So retardation is nothing but retardation. When you are writing retardation, you need not write the minus symbol. So retardation is equal to 8 units per second square. This is the what solution is. Example 3, the displacement s and time t are related by relation s equals to t cube minus 10t square plus 5t minus 4. Find time when acceleration becomes 28 meter per second square. Solution, we are having s equals to t cube minus 10t square plus 5t minus 4. First we'll find out velocity. So velocity v nothing but rate of change of displacement, that is ds by dt equals to differentiation of t cube minus 10t square plus 5t minus 4 with respect to t equals to 3t square minus 20t plus 5. Now acceleration a nothing but rate of change of velocity dv by dt equals to differentiation of 3t square minus 20t plus 5 with respect to t equals to 60 minus 20. but so that is acceleration is 60 minus 20, call it as equation number 1. But acceleration also given as a equals to 28 meter per second square. We need to find when acceleration of the particle becomes 28 meter per second square, and the acceleration, the relation for acceleration is given by a equals to 60 minus 20, that is we already obtained. Therefore implies 60 minus 20 equals to 28, 60 equals to 28 plus 20, 60 equals to 48. So t equals to 48 upon 6 equals to 8 seconds. So time t equals to 8 seconds. T equals to 8 seconds when acceleration becomes 28 meter per second square. Therefore time t equals to 8 seconds is required solution. Example 4, the displacement of particle s equals to 5 t cube minus 4t square plus 2t minus 5. Find displacement and velocity of the particle when acceleration becomes 52 meter per second square. Now we need to find velocity. Velocity nothing but ds by dt. So that is equals to differentiation of 5t cube minus 4t square plus 2t minus 5 with respect to t equals to 15t square minus 8t plus 2. This is velocity. Now acceleration a equals to dv by dt. Therefore differentiation of 15t square minus 8t plus 2 with respect to t equals to 30t minus 8. That is the acceleration. And in the question, acceleration equals to how much? 52 meter per second square, implies 30t minus 8 equals to 52. Therefore 30t equals to 52 plus 8. Therefore 30t equals to 60 and t equals to 60 upon 30 equals to 2 seconds. So at 2 seconds the acceleration become 52 meter per second square, and we need to find displacement and velocity of the particle. Acceleration becomes 52 meter per second square. So when acceleration becomes 52 meter per second, so that time the time lapse equals to 2 seconds. So we have the s equals to 5t cube minus 4t square plus 2t minus 5. So displacement at t equals to 2 seconds, how much? That is s at t equals to 2 seconds equals to 5 into 2 cube minus 4 2 square plus 2 into 2 minus 5. That becomes 5 into 8 minus 4 into 4 plus 4 minus 5. That is 40 minus 16 minus 1. 40 minus 17. That is 3 and 2. So 23 meters. After that we need to find velocity. So velocity nothing but, what was the velocity? So we have v equals to 15t square minus 8t plus 2. Now putting t equals to 2. So we get here 15 into 4 minus 8 into 2 plus 2 equals to 60 minus 16 plus equals to 46 meters per second. Example 5. A particle moving according to law. Find the velocity of the particle at the beginning. So we have s equals to 5t cube minus 4t square plus 2t minus 5. So displacement of particle s equals to 5t cube minus 4t square plus 2t minus 5. Now velocity. So velocity v equals to ds by dt. So that is differentiation of 5t cube minus 4t square plus 2t minus 5 with respect to t that is equals to 15 t square minus 8t plus 2. Now velocity at the beginning, that is t equals to 0. Velocity at beginning. To find velocity at beginning, put t equals to 0. So v at beginning equals to 15 into 0 minus 8 into 0 plus 2. So that is 2 units per second, because the system is not given. We don't know under what system. Therefore, we are writing 2 units per second. If radius of soap bubble increases at the rate of 2 centimeter per second, find the rate at which its volume increases when its radius is 3 centimeters. Now it is a soap bubble and it is increasing. So the radius is increasing at the rate, that is a dr by dt. Dr by dt given as a 2 centimeter per second. And we know that volume of the sphere is given by 4 by 3 pi r cube. Now differentiating both sides with respect to t. Why with respect to t? Because both are changing with respect to time. Therefore, so we have dv by dt equals to 4 by 3 pi and derivative of r cube with respect to t. So that is dv by dt equals to 4 by 3 pi into 3r square into dr by dt. Now dr by dt nothing but 2 centimeter per second, and the rate of change of volume, that is dv by dt equals to 4 by 3 pi into 3r square into dr by dt. And we need to find the rate at which volume is increasing when radius is 3 centimeter. So r equals to 3 centimeters. Therefore, dv by dt equals to 4 by 3 pi into 3 into 3 square, and dr by dt is 2. So 4 by 3 pi 3 into 9 into 2, this and this get cancelled, equals to 72 pi. So dv by dt nothing but the rate of change of volume nothing but centimeter cube per second. So this is the rate of change of volume, and this is required solution. Example 7. A stone dropped into a quiet lake and waves spread at a speed of 2 cm per second. Find how fast enclosed area is increasing when radius of circular wave is 8 cm. Here what you have done, you dropped a stone in water. What happened? The waves are producing. The waves are spreading in form of circle, and the radius is spreading. The radius is spreading at the rate of 2 cm per second. That is dr by dt is given, that is 2 centimeters per second. And we have to find out how fast area is spreading, that is dA by dt equals to question mark. And we have to find dA by dt when r equals to 8 centimeter. So we know that the area of the circle is given by pi r square, and area is changing with respect to time. Therefore, differentiating with respect to t. So we have dA by dt equals to differentiation of pi r square with respect to time, that is pi into 2r into dr by dt. So dA by dt equals to pi into 2. What is r value? You have to find out dA by dt. You have to find dA by dt when r equals to 8 centimeter. Therefore, here I am putting r equals to 8 centimeter, and dr by dt value is 2. Therefore, the dA by dt, that how fast the area is spreading, that is r equals to 8 centimeter, is nothing but 32 pi centimeter square per second. So this is what? How fast enclosed area is increasing. So answer is the enclosed area increasing at the rate of 32 pi centimeter square per second. This is the solution. Question number 8. The radius of spherical body increasing at the rate of 1 mm per second. Find the rate at which its surface area increasing when the radius is 3 centimeters. Solution. Here the radius, the rate of change of radius, that is dr by dt, is given as 1 mm per second, that is equals to 0.1 centimeter per second. Now surface area of the spherical body is given by S equals to 4 pi r square. We need to find the rate of change of surface area, that is ds by dt when r equals to 3 centimeter. That we need to find out. How to find that? First of all, we are having S equals to 4 pi r square. Differentiating with respect to t, so ds by dt, that t is nothing but time. So 4 pi and 2r and dr by dt. So this is equals to 4 pi to r value 3 centimeter and dr by dt 0.1 centimeter per second. This is equals to 4 pi into 6 into 0.1, that equals to 24 pi into 0.1, that equals to 2.4, and it is the area, therefore centimeter square per second. Now here is the next example. If y equals to x cube minus 33 upon 2x square plus 72x, find the value of x for which the rate of change of y with respect to x equals to 0. We have y equals to x cube minus 33 upon 2x square plus 72x. Here rate of change of y with respect to x, that is nothing but dy by dx. So differentiating both sides with respect to x. This is equals to 3x square minus 33 upon 2 into 2x plus 72. 2 to get cancelled. After that, taking 3 common, x square minus 11x plus 24 equals to 0 implies x square minus 11x plus 24 equals to 0. Now taking the factors, x square minus 3x minus 8x plus 24 equals to 0. So taking x common, x minus 3, taking minus 8 common, x minus 3 equals to 0, implies x minus 3 into x minus 8 equals to 0, implies x equals to 3 and x equals to 8. Therefore, the rate of change of y with respect to x becomes 0 when x equals to 3 and x equals to 8. So this is what solution. Example 10. A ladder of length 3 meter rests against a smooth wall standing on a smooth floor. If the ladder moves away from the wall at the rate of 0.1 meter per second, find the rate at which upper end moves when the lower end is 1.2 meter away from the wall. First of all, let us draw the diagram. This is the wall and it is the ladder. The length of the ladder is 3 meter. Let us say height of the wall is y and on the ground it is x meter away. So the first relation we get x square plus y square equals to 3 square. Now second is given, we have to find the rate of change of upper end. That means we have to find out dy by dt. Dy by dt we have to find out because the upper end is coming down as the lower end is slipping away from the wall. So we need to find dy by dt equals to how much. And the lower end is moving at the rate of 0.1 meter per second. That means dx by dt given. Dx by dt equals to 0.1 meter. And we need to find out dy by dt at at x equals to 1.2 meter. So x equals to 1.2 meter away, then what is the value of dy by dt? So we have x value 1.2 meter square plus y square equals to 3 square. So y square equals to 9 minus 1.144. So we get y value is equals to 2.74 meter. After that, we have the x square plus y square equals to 9. Differentiating respect to t. So dx by 2x into dx by dt plus 2y dy by dt equals to 0, implies dy by dt equals to minus x upon y into dx by dt. Now putting all the values, there is a dy by dt. So dy by dt equals to x value 0, x value 1.2, y value 2.74, and dx by dt value 0.1. So this becomes minus 0.043 meter per second. So this is required solution. Example 11. A bulb is hung at a height of 20 meter above the ground. A man of height 2 meter height is walking at the rate of 1.1 meter per second. Find how fast man's shadow is lengthening, how fast tip of shadow is moving. We need to answer the two things here. Now we'll start the solution. And what we have to find out? We have to find out how fast man's shadow is lengthening. So for that, let us call am equals to x and mt equals to y. So let am equals to x, mt equals to y, and at equals to z. Now for triangle A, B, T and M and T, we can write AB upon MN equals to AT upon MT. What is AB? AB equals to 10, MN equals to 2 equals to AT. AT is nothing but x plus y. MT equals to y. Here we can cut down this. So we get 10y equals to x plus y, implies 9y equals to x. So we get here y equals to x upon 10, x upon 9. dy by dt equals to 1 upon 9 into dx by dt. So dy by dt, what is given in the question? The dx by dt. dx by dt equals to 1.1 meter per second. Walking at the rate of, the man is walking at the rate of 1.1 meter per second. So that is dx by dt equals to 1.1 meter per second. So 1 upon 9 into 1.1. That is nothing but 11 upon 90. So that is roughly equals to how much? 11 upon 90. 11 divided by 90, that is equals to 0.122 meter per second. So how fast the man shadow is lengthening? The man shadow is lengthening at the rate of 0.122 meter per second. Now we have to find how fast the tip of the shadow is moving. For that, let us call this length as z. Now again, AB upon MN equals to AT upon MT. AB nothing but 20, MN nothing but 2, AT nothing but Z, and MT nothing but Z minus X. We have to correlate Z and X. Therefore, 2 ones are 10, cross multiplication 10Z minus 10X equals to Z. So 9Z equals to 10X. So Z equals to 10 upon 9X implies dz by dt equals to 10 upon 9 dx by dt. dz by dt gives how fast the tip of shadow is moving. So that is 10 upon 9 multiplied by 1.1. That is equals to 1.22 meters per second. So after going through all this problem, one thing is clear, that the application of derivative is quite easy chapter, and the rate measure problems are the easiest compared to any other difficult problem. I hope now you got a little idea how to handle the problems related to rate measure. You keep on solving more problems from your textbook. If you find difficulty, please contact me on my email address provided in the description box. Meet you again with another topic. Before saying goodbye to you, I would like to request you like, share and subscribe the channel so that you will be keep on getting the new videos as soon as I publish them. Wish you good luck, all the best. Bye bye. Meet you again.